Hey YouTube, welcome to my next episode on differentiation. We're on episode 6 now. Today we're going to talk about stationary points. So what does it mean for a function to have stationary points? So if you look at my diagram here of just a random function, what does it mean to be stationary? Now the way to think about it is, say you had a ball and say you put the ball here and you dropped it. What would it do? It would start falling, because what we learned last lesson is it's a decreasing function here. Then it will go to this bottom bit here, and the ball might just start bouncing from side to side and eventually stop moving here. It's stationary. And that's why mechanically we call it a stationary point. Another point would be up here. If you took that ball and you managed to place it perfectly, the ball would not move. And then the last point is here. Now, in some aspects of physics and mechanics, we like to define these points a little bit more. Not really in A-level, but this is just for your interest. This point here is known as an unstable stationary point. Now, the reason for that is, say you took this ball and you just pushed it ever so slightly to the right, it would just go flying all the way to this other stationary point down here. Whereas with this stationary point down here, if you pushed it to the right, it would go up, then it would just come straight back down. So we'd call them this minimum point, we would say, a stable stationary point. And up here we have a maximum. Now what's special about all of these? Well, it's to do with the gradient. The reason that they are stationary is because the gradient would be 0. If you did draw tangents here, they would all be flat. Yeah, so the gradients at all of these are 0. So last lesson we looked at increasing, decreasing functions. This part of the graph is a decreasing function because the gradients are all negative. Here, the gradients are all positive, so it's an increasing function. Here, where we have the gradient being flat, or the tangent being flat, we would say it has 0 gradient. So dy by dx at stationary points is 0. Now, just a little bit of an extra classification here, because sometimes they put it in exams, is this point up here, we call it a local maximum. Now, why don't we just call it the maximum? Yeah, when we think of maximums, we think of, like, if you think about mountain, you have the top of a mountain, we call that the maximum. Now, the reason we call this a local maximum is because it's not actually the largest part of the graph. It's not the largest y value on the graph. If we go horizontal, yeah, we can see these other y values have the same y value as the local maximum, but these portions of the graph are actually bigger. Yeah, so those y values are larger than this maximum value here. So we call it a maximum because if I was to draw a box around it and just localize the graph to just this part, then this section here is the maximum of that localized section of the graph. So just keep an eye on that. When we see exam questions, we're going to see local maximum sometimes rather than just the global maximum, we would say. Hey guys, I hope you're enjoying the video. If you're new here and you want more maths content, then please consider subscribing. If you're learning something, then hit that like button and comment down below to let me know what you want to learn next. I hope you enjoy the rest of the video. So let's just do some questions. So it's all really just algebra. We know how to differentiate. So find the coordinates of the stationary points on the curve. F of x is 162 over x plus 3x squared. So we know stationary point or points means to differentiate, and the gradient has to be 0. So the first thing we can do is rewrite this as 162x to the power of minus 1. Yeah, we bring up the denominator, plus 3x squared. Then we are going to differentiate. We're going to bring down the power. Minus 1 times 162 is minus 162x. Take away 1 from the power. And here bring down the 2, we get 6x. Knock 1 off the power is power 1. Make that equal to 0. Now remember, when we solve, we do not like negative powers. So we're going to rewrite this as minus 162 divided by x squared plus 6x equals 0. Now we're going to get rid of denominators, times through by x squared. Take the 162 over, divide by 6, cube root that, and we get x is 3. Now the last thing we want to do is we want the stationary point. So we need to find the y value. So we're going to sub in f of 3, which will be 162 divided by 3 plus 3 lots of 3 squared. And we could put that in the calculator. And you get 81. So our stationary point here, singular, is 381. Prove that the cubic y equals 2x cubed minus 3x squared plus 4x minus 4 has no stationary points. Well, we still need to observe the stationary points and show that it can't exist. So we still need to differentiate it, dy by dx, and see what we're left with. So bring down the 3, 2 times 3, 6, x, knock 1 off the power squared, minus 2 times 3, 6, x, knock 1 off the power. Then we have plus 4. Now we've got to determine whether this has solutions or not. Yeah, for stationary point, we're going to make it equal to 0. We can divide through by 2, sorry. So we get 3x squared minus 3x plus 2 equals 0. Now to prove that this does not have stationary points, we need to somehow show that this quadratic has no solutions. And now we're not allowed to just type this in the calculator and say there's a math error. How do we prove that quadratics do not have real roots? Well, we use the discriminant, don't we? We observe b squared minus 4ac. So let's do that. We have minus 3 squared minus 4 times 3 times 2. So we get 9 minus 24. And you can see immediately that this is less than 0. Yeah? Or you could say, I guess you could have simplified that to minus 15. But essentially, we're saying that is negative. So there's no real solutions. Yeah, no real solutions to this quadratic. Therefore, the cubic has no real roots. And that's proved. With all proof statements, make sure you just write a little statement at the end. So that's it, guys. That is an introduction to stationary points. Stay tuned for the next episode. We're going to look at classifying the stationary points, meaning when you have the coordinate, is that a maximum point, is it a minimum point? So, and an inflection point. So we will also check that in a future episode. So if you learned something, make sure you hit the like button and make sure you're subscribed for future maths content. And I look forward to seeing you in the next video. Peace.